Welcome to this panel. I'm going to be introducing three friends here. Actually, they joined us this week at this idea we created a couple of years ago called the Montevideo Tech Summer Camp, with the initiative to invite people working on streaming media and video technology. Thankfully, this year we have Alex Zambelli, we have Bhavesh, Upadhyaya, sorry, and David Hassoun. But we also have more visitors in the audience. We have Barry Owen here. We have, is it Occhialini? Like, okay, Casey Occhialini and Gunnar. Gunnar actually speaks Spanish, so he lives in Spain. And they're joining us during this week. They work in different areas of streaming media. Probably they create some of the technology that we see when we watch some sports or movies or series online in any of the famous platforms. We're going to try to make these like a conversation. So feel free to jump in if you have any questions, any comments, anything you'd like to know about the labs. That our purpose here is to, in the end, share with you our passion on why we do streaming media, what the challenges are in engineering and product management, and maybe why you'd like to know more about it and what we do. Many here in the audience also work at Qualabs. Maybe if you want to raise your hand. So many here do work in streaming media in Montevideo. I'm incredibly proud to have all of you guys here. It's something we wouldn't have dreamed a few years back. So together with Nico, the young guy over there next to the frame, we founded Qualabs 6+ years ago. We had been working in streaming media for a long time already. We both graduated from here, from Universidad ORT. We're both telecommunications engineers from this house. We were also professors at some point, some time ago. So we were in your situation, maybe a few years back. So I'm proud to, some way, we're giving back to you guys what the Universidad ORT gave us when we studied here. So maybe you want to introduce yourself, guys, what you do and what you're like, how long you've been in streaming media. Maybe let's start with you, Alex.
Sure, thank you, yeah. So thank you for having us here tonight. This is really, really great. So my name is Alex Zambelli. I've been working in the video industry for 22 years now. So at the moment, I'm a product manager at Dolby Labs, and you might be familiar with Dolby because you might see the logo on your audio video receiver at home or on your TV. So Dolby specializes in audio and video technology. Before Dolby, I worked for several years at Warner Brothers Discovery. I worked on the streaming service that actually just launched here in Uruguay last week, I believe, called Max. It's the replacement for HBO Max. So new streaming service with a bigger catalog. So I worked on that streaming service. Before that, I was at a US-based company called Hulu, another streaming service that's only in the US, but I think some people have heard of it as well outside the US. Before that, I worked for several years also doing product management. All these jobs were product management jobs. So I was at a small startup called Ice Cream Planet that built live encoding, video encoding platforms. And then really like started my career was 10 years in Microsoft. So that was my first job out of university was Microsoft. Started there as a software engineer, software test engineer actually. So I worked in quality assurance. Yeah, I worked at Microsoft for 10 years working on various media technologies there. And then slowly kind of transitioned into product management. And I'm sure we'll talk more about those types of career transitions. You know, I've been focused on media really for my entire professional career. I felt like, I got into it at the right time because digital media was emerging in the late 90s, early 2000s when I got interested in it. And so I feel like I caught this wave and have been riding it ever since. So it's been fun.
Was that when you were hacking like blockbusters? Or?
Yes. Yeah, we can talk about that too. Yeah.
Excellent. What about you, Bhavesh?
Bhavesh Upadhyaya. I'll take Alex and I'll move forward now from that time with Microsoft because that's when I met him. 2007 and 2008, we started working together. I was working for a broadcaster in the United States called NBC, and they had the rights for the Olympics. And my responsibility was to, and I know the physics professors here and some engineering students as well too. I was not in the digital media space at the time, but I had a good engineering mindset of being able to look and analyze a problem and look at the flow of one problem to the next. And so they told me to say, look at broadcast television and figure out how to turn that into online streaming. And so we worked with a bunch of partners after that point to figure out, well, how do we start and solve this problem of taking broadcast sports events in Beijing and get them to the United States and make them so that it's available to watch on the computer. And that was the beginning of our friendships, and then I joined iStream Planet, which is the same company that Alex talked about, and I was their head of operations, and so we worked on figuring out how to work with satellites, work with live event management, work on software to create the tools that help manage the live events, working on how to insert ads inside the streams, and building everything on from that point forward. And I'll pass it on to David in a second because that's where he jumps into the story as well too. We're all friends from a long, long time ago. We worked together for a long time. But the things that we did in that company are things that are now, you guys are able to experience. Putting massive scale live sports online on the internet, putting high volume events. We streamed the first Super Bowl in history. We brought the Premier League to the United States so that they could watch every match of the Premier League there. And through
many Olympics. So
the stress and planning and management of creating Olympics and putting it out so that it's available on the website for you. From there, I went on to run professional services for Verizon Digital Media, which is a telecommunication company over there, but they also owned a content delivery network and a video streaming platform. So we helped with launching Disney Channel online. We helped with ESPN3 to help ESPN allow them to do 100 events per day and manage all that. And then the last 3 years as the head of product for the video quality of experience for Discovery Channel, and then we bought Warner Brothers and became Warner Brothers Discovery, and really helping build out that platform for what Max is now today, to be able to see the health of everyone watching in all of the videos. No matter where you are in the world, you can see that you're having a healthy experience. And how do you look at all the data to aggregate that to say that 99% of all of our people are having a good time, the 1% is having an issue, let's go find out and solve their problem.
Thanks.
My name is David Hassoun. I started my career in this 26 years or so ago. I took a slightly different path, and instead of working initially or more recently, only started doing that for some of these great big name companies, I went off to start my own business, and I ran that for 18 years. And I got to work with amazing companies, work with these guys. I've worked on 6 Olympics, 3 Super Bowls, World Cup, thousands of other events. And I started in the creative side and development, then from there in engineering, creating the solutions around this, whether it be streaming infrastructure or developing the applications, the video players that actually make this stuff work at the last portion. And built a team of about 25 or so people in the end. And a little over 2.5 years ago, I sold my company. We were acquired by Dolby Labs, and I've worked with them for the last couple years. And it's been a fun transition going from a very small team, and I got to make all the decisions, to I have many bosses now. And working within there. And for me, some of it was difficult, some of it wasn't. It was easy because I always worked for a lot of these big companies. We got to work for some of the biggest ones out there and really cool, fun projects. but it's always different when you can't tell them, like, never mind, I don't want to work with you anymore. It's been a great experience, and now since being at Dolby, we first got brought into work on some advanced media delivery, where you can deliver out media across multiple CDNs simultaneously using network coding and some advanced technology that Dolby had been working on. And more recently, we've been switched over to help with the low latency side of things, where how can we create a better experience when you're working with trying to stream and have only less than a second of delay, and less than a half a second delay. What is the infrastructure needs around that? What are the player needs around that? And how can we create a better experience with that is what we're really focused in right now, and how we can also still bring in some of the traditional stuff like advertising and monetization and content protection, so that it can work in the way that the world expects the media to be delivered, and so companies can make their money off of it too.
Excellent. And you do have some shared experience. So you sometimes worked in the same company, but you also worked in different companies but collaborated together.
Yeah. So these guys worked at the same company for a number of years.
Twice.
Twice. At Ice Cream Planet and also at Discovery.
Warner,
Right? Warner Discovery. And while they were at Ice Cream Planet, my company realized we were doing work with NBC. It was a shared customer. But we would have to work together, like Bhavesh and I, a ton. We'd get like, hey, we have a problem. You guys just figure it out. Okay. We get on the call. We'd kind of brainstorm. We'd work through it together. And then we realized also did work for Ice Cream Planet. And Alex was the product owner on a project that we were working on for them. It's fun thing about our industry is you build connections over time and you find out that it's not that big. And you get to know a lot of people, and everybody knows where people are, and it mixes it all up.
Totally. And maybe you noticed, but they all have different academic backgrounds, but also different career paths. So is there any career path you're interested in? Is it software engineering? Is it product management?
Or operations.
Yeah, sorry. Also operations.
Or being a CEO.
Yeah, start your own company.
Yeah.
Starting your own company, selling it.
Mm-hmm.
Don't be shy.
Well, let's ask how many people are watching. Who has like Netflix accounts or watches sports online or watches things on demand or just YouTube or things like that?
All right, that covers about everybody.
We could ask the opposite. Anyone watching cable television?
Okay.
Hey, yeah, you have TikTok. So how do you think your academic background impacted your career path, and also, but on how much it was like the development of your career path that like had to do with more like the opportunities you had along the way? Mm-hmm. Maybe you want to give it a go?
Sure, yeah. So I studied computer science. So I got my bachelor's degree in computer science from Florida Institute of Technology in the United States. And when I was studying computer science, I honestly didn't actually know what other jobs there were in software besides development. I really just thought everybody wrote code. And I don't know if that was just, a result of my sort of narrow vision, or if, the school didn't prepare me well enough. But I really did think going into university that everybody just wrote code, and that's how that's what all the jobs were in software development. And so when I started out, out of college, when I started Microsoft, I got into software engineering, and specifically software test engineering, where I was really focused on testing software, writing test automation, right? So not even writing the product code, but writing the code that supports the product code. And I found it very interesting, but one of the things, I guess let me talk a little bit about what I found interesting about that. I really like the problem-solving aspect of it, and the troubleshooting aspect. And sort of, a lot of it was like, look, if you find a bug, it's not just enough to say, oh, I found a bug. You have to be able to reproduce the bug. You have to be able to actually consistently show that it happens, right? You have to be able to explain why it happens, what are the circumstances that lead to it happening. And so a lot of it really is sort of like playing detective, right? And so I thought that was a very interesting part of that job. So I enjoyed it, but at the same time, the more I worked at Microsoft, the more I saw that there were other jobs that you could do in the software industry that had nothing to do with coding, right? You didn't have to write code for everything. And so one of the disciplines that really appealed to me was product management. I liked the idea of being able to design software and write specifications describing how it should work, and how that trying to address customer requirements and different use cases. So I thought that was interesting. Like to me, like that felt like a very creative job in the software industry, right? So like being a writer or a director or something, it's like, okay, you're creating the film, right? You're creating the song. And so I started looking for ways to get into that discipline. So eventually I did work my way towards it. For a while actually I did a job that was basically like a technology evangelism job, where my job was to go out to trade shows and conferences and talk to customers and do talks at different shows, like to basically just talk about the software that we were working on. So at the time, for example, we had a brand new streaming technology at Microsoft called Smooth Streaming, and it was the predecessor of the technologies that are used for streaming now these days. And so it was a brand new thing. Nobody knew about it. And I literally would go and do talks at conferences just describing, hey, this is this technology we created. Here's how we used it. And I wasn't trying to sell it. I wasn't trying to land any deals with it. It was really just like information, just sort of like communicating, how software works to people. And then as part of that job, I got also then involved with a lot of these high profile streaming projects that Microsoft was partnering with other companies on, like with NBC on the Olympics and others. And so it then also became sort of like a solutions engineer job as well. And so the more I did that, the more I realized, oh, really, if I wanted to do a product management job, I think I have the skills for it, because everything I was doing, right, like really like talking about the software, describing how it works, creating solutions for particular projects. I mean, that's what a product management job is. And so that gave me the confidence to eventually go into product management. And so I felt that the career path that I took to get there, gave me certain strengths that, other product managers didn't have. So because I came from an engineering background, I had a much better technical understanding of how software worked, of how software engineering worked, right? How to talk to developers, how to basically look at problems from their perspective, and not just say, well, here's a spec and go implement it, go figure it out, right? But really kind of work with them and collaborate with them. And so I thought those were really the strengths that I think made me a successful product manager, is that I went in it with a sort of the looking at it through the eyes of an engineer, and really put the focus on the technical aspect of product management, not really just the business side of it.
I like it because you never say that I was a Java expert or a backend expert, but
Yeah.
you found other areas of engineering and applied software engineering, not necessarily in coding.
Exactly, yeah. That was sort of the thing that I didn't expect when I was studying computer sciences. I didn't realize that there was other ways you can express yourself and express your passion for software that doesn't involve necessarily writing code. There's other things you can do, right? And so, yeah, I felt like I ended up sort of being guided by what looked sort of more creative, more interesting to me, and just really looking for a better way to express myself and express this passion that I had for software.
Okay. And David, in your case, it was like you started in, was it 3D graphics?
I started in graphic design. So yeah, I only got a 2-year degree in graphic design, and from there, I loved graphic design. I was engaged there. I started interning when I was 16 in that field, and my passion though was all about how you can take these beautiful visuals and make something that was interactive, something that could go beyond that, and a big drive towards video. Back then, video was more limited, not so much on the web, but. From there, that's where it drove into working within multimedia at the time, and video and encoding, and eventually towards the streaming space. And that's when I really shifted more into engineering development side for a number of years until I just stopped writing any code because I had too many other meetings to go to. And that turned into my life for like a long time. But what still was my passion and still drove me and still drove a lot of the success of our team was the ability to take challenging problems and come up with a good solution. Oh, we can use this technology and pair that with this. I didn't have to write the code, but I could figure out the pieces and parts of what we needed and the team we needed to assemble to be able to execute and deliver on something. And that's something that we think is really valuable that you're able to get out of that and that critical thinking element that I gained within school and that knowledge, and also teaching was a great way to hone those skills as well, as I taught for an adjunct professor for about 10 years as well at the university in Denver. So that those kind of how it became my foundation for how to continually drive and build teams and build solutions and the career.
Excellent. So someone designed a product and someone built it, but then so many people had to operate it, to troubleshoot it, to make it actually work for everyone, everywhere, all the time.
Yep.
How was it for you? Like, how was your evolution? That's it.
I studied mechanical engineering. So
What's our mechanical engineering?
Mechanical, yeah. So my big thing is, that's why I love physics. How do systems interact with each other? How does, from like heat transfer work? How does airflow work? Something is impacting something else. So everything is breaking down into what do you have and what is the touch? Now, how do you break down every problem like that? One of the problems that Alex talked about is, we're delivering video. What is the number one problem? You kids probably don't understand what buffering is. In the olden days, we actually had to download an entire video before we could start watching it. That means you can't do live at all. And if you were starting to watch in the middle of the download, you didn't have the entire video on your computer, and it would just spin and buffer. And it would just be the one resolution. So Alex's concepts and code actually created a way to chunk the video so that you only got 2 seconds at a time. And 2 to 4 seconds or whatever. But either way, you now could create 10 versions of your video. And based on if you were on a mobile device, if you were on your home computer, if you had 3G, 4G, 5G network, or you're on Wi-Fi, now you could automatically, every 2 seconds, figure out what's the health of your connection and give you a better video. Or if you lost your connection, reduce the quality so you still get the video, but at a lower resolution, but you still watched it. Our concept, our goal is the show must go on. The video needs to keep on playing. So how do we then, that's our purpose, give you the video and now solve all the problems of how does the internet work? How does 5G networks work? How does a broadcast system work? How do you put all that stuff together so it doesn't fail? And when we look at systems like video and broadcast, you're looking and saying, well, how do I schedule a show? How do I schedule a live event? How do I manage 50 live events at the same time? How do I map that from a piece of paper or a schedule that has 50 live events to, well, what video signals does that mean? Where do I tie that to a device that's going to record that and make a video out of it? Where do I tie that information to a website or an app that lets me know, how do I find that? If I want to find all the videos for swimming or football, or I want to look for only the Uruguay team's Olympics games. I want to be able to search for that, find that information, and find the link and watch the video. I don't want to think about the technology behind it. So it's our job to figure out where can that process fail? What do I have to do to, when it does fail, because everything will fail, what am I going to do to make sure that it's still working and gets fixed afterwards? When you think of things like that, you think in terms of priorities. What is the most important thing to do? What is the next important thing to do? What is the next important thing to do? And you look at your purpose of, I want to deliver video, so these are the most important things. After that is, I want to make money, so I want to make sure the ads go. I want to make sure that the right people are watching, so I have user IDs, passwords, etc. I have to manage all that. So all that becomes part of what you're trying to do, and it's all based on like engineering, good engineering, systems thinking, and systems design that says, how does one piece work with the next, and you just build off of that.
Excellent. And you do have some war stories together, right?
Oh, so many.
So many. So was it Beijing was the first HD transmitted?
Vancouver.
Vancouver was the first
Olympics,
HD
yeah.
transmitted.
2010. 2010, yeah.
2010.
Yeah.
And what was your first Olympic together, the three of you?
Sochi.
That was
2014?
2014?
Yeah.
And,
But we had worked on the Super Bowl and a bunch of other stuff before that even. So
and so these are different events because the Super Bowl is like only one night.
Right.
yeah,
Probably
Cannot fail.
5-6
Cannot
hours.
fail.
You
Right.
know about it.
Yeah.
Just one night. So Casey works for Paramount, and they had the streaming for the Super Bowl this year.
The
And I
Taylor
think there are
Swift
some
Super
public
Bowl.
numbers, like more than 7 million people on streaming ish. That's what I read.
Over 6.
6-ish.
Yeah.
It was a huge Super
Was it? Okay.
at peak.
Yeah.
So imagine 7 million people watching the same stream on all different devices. It's not just the iPhone and Androids, but all connected TVs and Roku's and computers and like whatever people can connect to the internet and watch and stream. And probably for like Super Bowl is huge and a lot of money, but also like the Olympics probably have tens of feeds coming in and all happening at the same time.
75 around feeds that we have
Feeds,
to manage
yeah.
and
at the same
figure out.
time.
And every one of them feeds is running 24 hours a day. So you have to figure out when it's important for it to start capturing and end capturing, and you have to know what's there, and you have to keep track of weather delays, timeouts, or games that extend further out, and the schedule is shifting. So before it was on this feed, now it's on this feed. How do you manage all that information changing around and still not fail so that when somebody says, I want to watch this match, it should be the right one, regardless of when the schedule changed?
Again, what did the three of you learn? Like, if you want to kind of share like an experience of how it was from your perspective, working an event like these, like the Olympics. How was it preparing for it? And how was it during the event?
Mm-hmm.
And also how was it afterwards?
There was something that Bhavesh said earlier that I think you sort of casually said it, but I think it's worth repeating. So you said, you should assume that everything will fail. And like, that is so true. If you want to design a system well, you have to assume that it will fail. So if you think your system is perfect and it will never fail, it's probably not designed well. You should assume that things will fail, because that forces you to then design backups and redundancies and make the thing more robust, more stable. And so that was one of the big lessons, was that you can't over prepare. Like, you can't over provision. You should always don't assume that having one instance of a server is enough. Make sure there's 2 or 4. So that, to me, that was one of the early lessons, was that assume things will fail and make sure you have a backup strategy for when they do fail.
I think like the first Super Bowl we did, I think there was either 12 or 14 levels of redundancy just on the streams. So we had, if this one fails, you go to number 2. If 2 fails, you go to 3. And this could be for large numbers of users in different situations in different areas of the world. We have 14 levels of redundancy to make sure it went smooth. And in the end, we only used 1, maybe 2 for some. You keep it a little bit warm, right?
So, mind you, there's an economics behind this as well too. So the very first time you do something, you make sure you try for everything. After you figured out the right ways where things work, and you know where the most probable ways that things will fail now, you start then figuring out, well, how do I make this more efficient and start saving money? Because you can't always say, I will throw 100 servers for one stream. That doesn't make sense. But you figure out what the probabilities are of failures and say, okay, now that I know what will fail and I know how often it may or may not, I'm going to put things in place to prevent it. But I'm also going to try to make sure that we're not spending too much money for the sake of spending money. Let's make it so that it's more efficient in the future. But that the first time you do something, you have no idea what's going to fail. So,
and a key element of any major event too is also what we refer to as observability. You need to be able to look at any part of this complex system, delivery, player, infrastructure, encoding, transcoding, all of this, ingest, and be able to identify where the problem is. So observability, to be able to identify and isolate solutions, is critical, and that's both skill and that's also planning and architecture and how you build things right from the get-go.
And so when you did these events, how was it during the event? Because the other day, I think it was on Sunday, you were saying that you were working remotely from home No, totally the opposite.
No,
So-
we were
it's the opposite.
we were together. I would say that the event, by the time we did Sochi Olympics, we were just watching our dashboards. Everything was just boring, and that's exactly the way it needs to be. A most boring event, because we had spent the last months before that training and making errors and forcing ourselves to understand how would we behave as a human being, how would our systems behave, what are the things that we need to look at. So to David's point, like what are the dashboards we were looking for, how do you measure the stuff? We figured out as we were practicing things breaking, what do we have to keep an eye on? How do we measure the temperature of a system so that we know it's healthy, not a little bit sick, not bad yet, and now we're going to start seeing issues and we need to start. So we have an advanced warning of something to be fixed. So we do all that preparation well ahead of time. So by the time that the Olympics happened, every day we were just creating a marathon schedule. Someone just look at the stuff, make sure everything's running. But we knew we had all of the right tools in place and we had the right dashboard so that we knew the health and we knew what to do when things happen next.
Your memory is way better, way more positive than mine is of some of that.
I think he's describing the later events.
Yeah, the first ones, there was a lot of that preparation, and I think there was a lot learned out of it. Human error is a huge factor, right? So operators with all these streams going on, there's different people dropping ads, different people starting them up, and different configurations that you often need in these streams. And to put it simply, as I recall it was a shit show, is the term that we would use in the beginning, and then we settled down.
Yeah.
And the cool thing is with the Olympics, technically the Olympics begin before the opening ceremony. We're already running events and we're doing stuff, and we work out some of the kinks, get the flow down, and then we're able to move much smoother. And also that's what we learn, so that the next time, okay, how much of the human factor can we take out with automation, and with automation add observability so we can make sure the computer is not messing up. And doing what it's supposed to do. But so like the more you sweat up front, the less you bleed later. And being prepared is the way to do that. But even then, Sochi, it was, I got into their office at 5 p.m. and I left at 8 a.m. For a week and a half, no days off. And that was just to get it off the ground, and then I got to go home and we started swapping people around. It's a lot of work, but it was also really, really rewarding to be able to see that type of event go through and be able to be behind the scenes and be part of it and reach so many people.
And those early events, we did believe that we needed to be all physically present in the same space to really be able to communicate well and coordinate well. And so, I remember when we did the first, I think it was like Super Bowl in 2009, and then the Vancouver Olympics 2010. I mean, we all picked a location. It was, I think, in one case it was Las Vegas, in another case it was New York. And so we would pick a location, and there would be people from 7, 8 different companies that were all partnering on this project, and we would all come together in one place and make sure that we had sort of what we call a war room. Where
no windows.
No windows. For some reason, they were always without windows. I'm not sure why. But to increase concentration. That's probably
so
why.
No
No distractions.
And no Wi-Fi access.
Yeah, exactly. Well, no, we definitely
No,
have
you
Wi-Fi
need
access.
observability requires.
So we would make sure that we were physically present in the same room, so we could just react quickly, so that if something was you were observing a problem happening in sort of your side of whatever you were responsible for, that you could immediately go talk to the person sitting next to you and be like, hey, are you seeing anything on your end? And then figure out if you need to escalate and maybe get people on the phone, call them, if anybody else needs to be involved. And so, there's definitely an emphasis on, I think, physical co-location back in those days. These days with everybody, being used to working remotely, like maybe there's less need for it, but I think there's still a lot of value in it, I think.
I remember in the beginning, before we developed better tools, David's team actually created a single video player that you could look at them, like 45 or 50 streams at a time. So we were able to see every event of the Olympics on the stream, the primary and the backup streams. Later on, we got better tools where we didn't really need to look at the video streams anymore now. Now we just needed to look at this nice little, we called it the Christmas tree, which simply says, here's all the things, and it's red, yellow, green. And we just looked at that instead because we could see that everything was green. Because now we knew enough to know what we had to measure, and we knew when it was healthy and not healthy, so we looked at the Christmas tree most of the time to make sure the Christmas tree was good. And we kept the video stream just so we could watch what the sports were.
All these was just before the iPhone and WhatsApp and all that. So it wasn't as easy as today. Like communications wasn't like today and
Right.
all that. But you're also working on streaming media now. And there's been a lot of development in streaming media in all these years. So so all these was before Netflix. But at least the streaming Netflix we all know here.
Yeah.
Netflix came to Uruguay, I think, in 2012, 11, 12. So imagine all these stories are even before the Netflix streaming here, at least in South America. What challenges are you seeing now in streaming media? Like, why should someone actually work on it?
I'll pick up.
Sure.
When we started working on it, video was only available through a web browser. Now it's available in not just your car devices, but your mobile devices, but in car, in small little screens in different parts of the room, in refrigerators. They have screens now. There's screens everywhere, so video is being pushed everywhere. And now the challenge in the beginning was developing a video player in a system that worked on only a few browsers. Now it's across hundreds of devices. I'm sure we were talking to Casey about, you know how many different television models there are out there? And every television now is a smart TV. So they have their own app for Netflix, their own app for Disney, their own app for, every one of those is a different piece of code that somebody wrote and had to push out just for that device. So you go from writing for a few web browsers to literally writing player code for hundreds of devices around the world in all different ways. And so how do you measure that and deliver video to all of that? The complexity is just exponentially increasing, not linear. It's an exponential increase. Every time you push something out there, it's another thing you've got to test and validate. And you can't forget the old devices. Our biggest headaches are the 5 and 8 and 10-year-old TVs or Rokus that are still functional and working, and you can't just tell somebody, throw it away and buy a new one. You have to make it work for that and the latest 8K TV that's being delivered.
And so I mean, I think there's a couple of interesting things, and two very distinct areas I see as really cool potential in the future. One is a big kind of problem that oftentimes overlooked is that the internet in its current form and in many ways is finite, right? We are starting to have more and more capacity issues to be able to deliver things at the quality and the experience that people want at a whole, even with CDNs, and there's limitations there. We're trying to add new technologies, things like referred as like open caching, drawing more ability to deliver things closer to users. This is a problem that doesn't have a real solution yet. There are band-aids. Innovation opportunities are huge. This is when like the industries really change, and then a massive opportunity becomes out there to solve some of these challenges because the demand is growing so fast. But then also on the other side, like the demand is there, but the engagement is really starting to drop. People's attention spans aren't maybe what they used to be. And ultimately, you know, nowadays, very few people will sit down and watch an event for 3 or 4 hours and stare only at that one screen. They're going to have their phone too. They're going to be doing other things. What's that new experience beyond just showing a square video that's really going to change the world and become the new standard? And there's things, you know, AR, XR, you know, the new Apple headset that we're seeing potential for the future. It's not here yet, right? The ideas that you guys in this room can come up with can really change what that future is and create tremendous opportunity and really exciting new stuff, because there's a demand there. People want something different, something new, because great, we can deliver best quality now and you can't tell if it's any better. Well, then what? We always want something better, want something new. What is next and new? And I think we're going to get to that inflection point in the near future.
I mean, it's interesting to think about the fact that like the current streaming technology that's used for pretty much delivery of any video you're watching. I mean, with the exception of video calls, which is a different type of technology. But if you're watching TikTok, if you're watching Instagram, if you're watching Netflix, if you're watching Max, doesn't matter what the service is, it's all based on the same HTTP based adaptive streaming technology that's now 15, 16 years old, right? In software, that's a long time, right? That's a long time for a technology to be static, not have changed, which means we're probably due for another big sort of seismic change, right? Like another big disruptive change that's completely going to change the way we do streaming. I think it's coming. It has to, right? Because exactly of the problem of capacity that you talked about. Like, I mean, we're filling the pipes at this point to a degree where it's not sustainable, right? We have to figure out like different ways to do streaming. And so there's definitely opportunities, I think, to do innovation and to do something disruptive because, 15, 16 years ago, like we were kind of in the same boat where like we had a different type of stream technology at the time and it was reaching its limits. And then somebody went and said, hey, how about this other thing? And everyone went like, yeah, that's a great idea. Let's do that. And then that became the standard for the next 15 years. So yeah, I think we're due for another big change.
One of the things I want to bring up is in the invitation for this meeting, you talk about internet being 85% video traffic right now. And if you can imagine the traffic jams right now in the city, 85%, it's not like a standard 85% across the board. It's going to be, parts of the internet will be quiet. And then like on the Rambla, everyone's trying to drive on that same road right now. And so you're just creating a massive traffic jam. So imagine the internet is like that as well too. That's what we're talking about capacity. It's not capacity as a whole, but capacity to where you want it. When you're at your house, when you're on a cable network, if you're in Montevideo versus another town, you have more bandwidth here. You might have slower bandwidth there, but you still want to watch video there. So the traffic capacity is increasing, but the network, the roads, in essence, are not being created as fast. And so that's why you have to solve it. How do we solve it with software? How do we solve it with different operational flows? How do we solve it with caching and moving the traffic around so that we're not creating these traffic jams? Because those roads are needed for emergency services. Then you can't just shove video and have that be the only thing on the internet.
Totally. So now the audience, do you have any questions? Anything you'd like to know? And also, if you want, we're also discussing what kind of pizza we should eat.
Yeah.
The square pizza, la típica de pizzeria, or the round pizza. So if you answer, you gotta say. You also have to say if you suggest the round pizza or the square pizza.
I can suggest the square pizza. You have to try it.
Okay.
It's really tasty, and you have to try it. That's all I can say.
Perfect. All right. Anybody else? Any other fans of square pizza? Like, hands up if you're a square pizza fan.
All right.
Okay.
How about for round pizza?
Oh. Yeah, it's gonna be square pizza.
That's good. Square pizza wins. Okay.
Yeah, square pizza
Excellent.
wins. This is democracy. Right?
Yeah.
Go for it.
When you speak about disruptive changes, for example, using AR, XR, or whatever, the amount of traffic needed for that, like if you want to live stream something that gives those kind of experiences, and Bhavesh says that the traffic is a problem, but even those problems are a problem. Like,
Yeah. So
going there is there's a big thing.
there's a fun thing. What Apple did to solve the problem right now is because their vision goggles track exactly where your eyes are. Everything outside of where your eyes are focusing is low resolution. Only those sections of where you're focusing your eyes on is the high resolution video. So as you're like moving around inside any stream there, it's only putting that in super high focus because it's constrained resources. So it's only going to apply the best resources for that part that you're looking at. So that's one ingenious way to solve the problem. How else can you come and figure out different ways to solve an issue of delivering that much data? Because the screen itself for the Apple Vision Pro is like what, 8K altogether? It's massive. So you can't, there's not enough bandwidth to deliver all that video. So there's smart ways that can be done to solve that problem.
And that's a really interesting opportunity, though, when you think about it as to towards the future, and this becomes more prevalent in these types of situations that require such high resolution that is non-standard for the streaming systems. The technologies are conflicting at times, right? So what can be done? Is AI codecs something that could look to eventually solve that, right? New technology that really is starting to become, I think, the future needs that isn't here yet. So, to me, the point to JP's question is like, well, geez, if everything's working so good right now, why do you want to go in this industry? It's not. Like, it's working okay. We're surviving. We got through the standards. We got the basics covered. but the world is moving to a direction that we're not ready for yet, and we need new solutions. So I think there's tremendous opportunity in the future, and it's a great time to get in there. Not to be like, hey, I want to be the HLS and and Dash Pro. That's just a part of it, right? That's how it was. And as Alex said, like it's 15 years old, right? What's next? And where you can go with that. And there's things starting to pop up, but it is going to be a tremendous amount of new work, new ideas. And once they finally start to settle in, then it's going to be all this over again, where it's the boom area of everyone trying to now adopt into it and grow in it and apply it.
But the one thing, if you noticed, and JP was talked about it earlier with us, so I want to add this into the conversation. We're not talking about programming languages. We're not talking about applications that we use. We're talking about problems and solutions. And so that's what we want you to think about is when you're studying, what's your purpose? What are you trying to solve? And then find the tools that will help you solve that problem. Don't study the tool for the sake of the learning Rust or React or things like that and think that's what, okay, great, I'm good at that. Become a problem solver. Think about what you want to do and then figure out the tools and what you want to learn to help solve that. Figure out what your purpose is.
And to add, maybe also for the career, I mean, we have to think it's an observant world right now. So to think video, as we said, right? So the one tool will get better all the time. Africa, Asia, they're just waking up, and before things they do rest, you can now see videos. So that's a market that automatically is growing. So it means for the future, for the next 10, 20 years, I would say longer. It's a really safe bet for the career. Because it will exist. And even if there are no new users, it will grow. The beauty, as we've said before, and this is also what I really like, is it's invisible for the end user until there's a problem, but it requires so much work before. And in the end, you see the result of what you did, like in other areas where we don't see the same.
I want to tag on to your point. That's a great point, Gunnar. I met a company representative from India who talked about how India leapfrogged in digital video watching when they made data free for mobile devices. All of a sudden, everyone started watching. And I think we were having a conversation earlier about using WhatsApp here. And in the United States, there's hardly any WhatsApp use. But because here, they charge you for every text, right? In the US, they don't. So everything is over text in the US. But so imagine a scenario now where, for you guys, if text was free, no one would use WhatsApp anymore. Now imagine when, even in here, when data becomes free or becomes so cheap that you don't care about it anymore. Imagine the explosive use of video now on your mobile devices when data becomes cheap. So those are the problems, the ways to think about what's going to go on in the world is look at the way, and Gunnar says about Africa and Asia, what's happening is that resources that you're using now that are very expensive, imagine what the world would be like when they were cheap or free. What could you do then? Imagine what it would be like, how would you use video if data on 5G was free? If your texting was free, everything was free. What could you then invent at that point? That's how you need to think about problems to solve.
And your battery lasts.
And your battery lasts
That's
longer.
separate.
But even like the underlying core technology is streaming. They're all old.
Okay.
The H.264 codec's been around, what, almost 30 years?
Right.
You know, so the internet itself, TCP, you know, it's not designed for video.
No.
So there's challenges at the very core of the technical stack from the bottom to the top that are ripe for some sort of revolution, right? All the new codecs are built on the previous codecs. There's really no change. They all work kind of the same way. You know, figure some other way to do it. You know, so there's plenty of roadway for innovation and being creative.
Totally. Any last questions? Because we're running out of time. If not, I'm going to ask you to give, like in a nutshell, like any recommendations. You already gave some good ones, Bhavesh, but if you had to say like a last message to the audience, what would it be? Go for it.
If you think there's something you can't do, you're wrong. You know, it will always come down to how much you're willing to put into something, right? If you're willing to sacrifice it all, you can have anything, and it's a trade-off, and that's okay. Like it's okay also to know where your limits are. But I would also, I mean, I wish I believed it when I was younger to expel that fear. That that'd be a really cool industry to get into, or that'd be something really neat that I'd like to do. But I don't have enough aptitude for that. I'm not good enough at that. It all comes down to how hard you're willing to work, and if you're willing to put in the effort and the time, there really is no limits. And you could be the person that comes up and solves this major issue that's going to change the world and the internet and streaming video or whatever else it is. But it will have a cost. Identify that cost and determine if it's worth it to you, and do it.
Love it. Thanks.
I'll add one more thing, which is you guys are all consumers of digital video right now. It's part of your entertainment and enjoyment. You, as engineers and computer science majors and things like that, have the ability to become developers of the same technology. So become more active. Don't just be a consumer of it. Make something with it, or make something about it.
Thanks.
My parting words would be find something that excites you, something that you're passionate about, that you're always curious about. So if there's an area of technology, whatever it is, doesn't need to be video, like whatever it is, if there's an area of technology that you're just genuinely curious about, like you can't get enough reading about it, you can't, you can't stop working with it because it's fun. Try to make that your job. Like try to find ways to basically get better at that, and try to basically direct your career in that direction. Because I think in order to sustain your career for a long time where you don't get bored, like you have to work on something that you're passionate about. If you end up working in software on technology that you don't care about, you're going to get bored at some point, and you're going to say, God, like, why am I getting up every morning? Like, there's no point, what am I doing this job for? And I think that's like a guaranteed way to be unhappy in your work, right? So I think if you want to be happy where you work and satisfied, I think you should pursue your passion. You should, find something that gets you out of bed every day, where you say, that's a cool problem to solve, and I want to solve it again today, right? And then the next day still feel like I still want to go and solve that problem, right? And so something that doesn't intimidate you but actually excites you. So if you can find that thing, then try to make that your career, because that's what's going to sustain you.